Okay, good morning, everyone. This is Wayne Matthews. I'm an application engineer with Progression. Uh, and today's topic is about SolidWorks utilities. Before I get into this, apologize for previous webinars that I've done. The last 3 or 4 of them, I've had issues with the recordings, or not really with recordings, but I think it was due to the recordings. But anyway, you were having some screen issues where it was flickering. Hopefully, I'm going to resolve it this time by actually recording it with Camtasia rather than using the GoToWebinar tool to record. So hopefully we're not going to have any issues this time. And if you attended any of the others, I do apologize for the problem, but hopefully we'll get it corrected finally. Again, today's topic is about SolidWorks utilities and how you can improve your design process, make it a lot faster. Before we get into it too far, of course, the interface has changed over the years. This is an old slide, but anyway, the webinar control panel. There's a red arrow to collapse and expand the control panel. Control panel is where you can chat. So if you have issues with the display, please let me know. I do ask that you hold all questions to the end, and then we'll have a Q&A session at the very end. SolidWorks Utilities. What is SolidWorks Utilities? Well, it's a group of productivity tools that are included with SolidWorks Professional. And to turn on the tools, you have to go to Tools, Add-ins, and check the SolidWorks Utilities. And I get asked quite often, what is in utilities? Well, that's what this topic is about. Myself, I really don't keep up with it, so I decided to go ahead and do this presentation to actually educate myself along with y'all. So here is the tools that are in SolidWorks utilities, or at least most of the tools. There may be a few of them that I've got missing here, but anyway, here's the most of the tools. We have a tool or tools to compare different types of documents. You can compare documents for like drawings. You can compare features. You can compare geometry. I do not have it on the list here, but we can also compare bombs, and I'll show you the bomb comparabilities. Uh, geometry analysis. Geometry analysis allows you to look at your geometry. I use it some for stress analysis. Sometimes you can have a model that's perfectly watertight, but then when you try to mesh it, you're not going to be able to mesh it. And you can use this geometry analysis to help find where in your model you're going to have trouble. If you do plastic parts, we have a thickness analysis. Symmetry Check. This is a new one that I wasn't aware of. But Symmetry Check allows you to check for symmetry in your model. Again, it's a nice tool for doing FEA analysis. We have a find and replace annotation, so you can quickly do a find and replace annotation on drawings, which is kind of a nice tool. If you change your change something, you can quickly make changes to all instances on your drawings. Another tool that's pretty nice is the find, modify, suppress, simplify features. So nice tool to quickly find small features, for example, simplify them by suppressing them, things of that nature. Feature paint is a tool to where you can actually basically paint the feature, then you can then do something with it. Power select is another nice tool to quickly select multiple things. Then also with the SolidWorks 2015, we have the ability now to save our selection, so we can use power select to select many items and then save it as a selection. So I'm going to get started here, and let's see, it's find where my SolidWorks is. let's get this out of the way. So basically, here's two models. Just by looking at them, they look the same, but we can use our compare features to see what differences are in the models with respect to features. I did not have to have the files open to start with, but if I have them open, then in my compare dialog box, I can then select the reference features from the files that are already open, or if I don't have them open, there's a browse button to browse for them. But anyway, I want a reference document will be clip 0, and my modified document will be clip 1. And items to compare, this time I want to compare features, and I'll just hit my run comparison. And it gives me a little summary information here as far as what's different between the two. Now the countersink hole, I mean, just looking at it, you'd think it's the same feature, but the end condition on this feature is different. On one, it's a through all. This one down here, you can see that it's a through all, that it actually cuts through that base plate. And this one up here is up to surface, I think. May be wrong on that statement, but anyway, you can see that the features are actually different between the two. The cut extrude feature, another one that doesn't really look like there's anything different between the two, but we'll see a little bit later on that what is actually different between the two. And then this last one here, you can quickly see that it's not on one model, that it is on the other one. And if you see the little chamfer features in red on one, then you don't see it at all on the other one. We do have the ability to save a report. And I'm going to save this, but I'm not going to open it up. I'm just going to view the report on save. And I've already got one here, override it, yes. And this is an HTML report about the comparison of features between these two parts. Unique feature, so here's our chamfer that's in the reference part but not in the modified part. Modified features, I've got the hole wizard, countersink, again looks the same here. Cut extrude looks the same here, but those are modified. They're in both models, but they're different. And if I go to details, for the hole wizard, the countersink hole, for the reference part, it's a through, and the end condition for one is, for the reference part, it's up to surface. For the modified part, it's through all. Now the cut extrude, on the cut extrude, again they look the same, but actually the report didn't show me as much as I was hoping for here. But if I look at the feature tree, my cut extrude 3, the sketch here is fully defined on my reference part, and the modified part, you can see that the sketch is not fully defined. So it makes it a little faster and easier to compare two models to see what features are different between the two. Next one I want to show you is actually the geometry compare. Again, very similar, but this is comparing geometry versus features. So now when I run my comparison, I have two different areas here. I can look at the volume comparison. So here's material removed in the modified part, and you can see that little sliver face due to the through all end condition on the one model. Material added. So there's the material added to the model. So I got my two chamfers, and since the one cut extrude is not fully defined. I got a difference in the diameter of one of the holes. I can look at my common volume, and this is basically behind the scenes just doing a boolean between them. I can also look at surfaces or faces. So unchanged faces. So here's all my unchanged faces. Here's my unique faces. Unique faces, it even considers the difference in diameter of that hole as unique. And there's a little notch from the through all. And there's the chamfer faces. And then here's my modified faces. So that's tools for comparing two models together, both the geometry comparison and the feature comparison. And I'm going to do a quick check to make sure I have no chaps. So look like everything is good with my method of recording using Camtasia versus GoToWebinar. Anyway, let's close out of our compare tool. I'm going to close these files and not bother saving them. And we're now going to do a compare BOM. Compare BOM you can run on both a drawing and assemblies, but it does require that the documents that you're comparing have a BOM in them. And let's tile these. And we'll go to our tools, compare, and this time we want to compare BOM. Again, just like we did with the other compare, need to tell it what reference document. So we'll use the reference document is 02 and the modified document 03 or 07, excuse me. And we want to compare BOMs. What BOMs to compare? Of course, you can have more than one BOM in a drawing or assembly. So we want to compare BOM 1, bill of material 1 for the 02 and the bill of material 1 for BOM 2. And what criteria, what field arose for the failed rows. And I'll just use description on that and hit my run comparison. Now this tool I'm not real impressed with, but just wanted to show it to you anyway. But anyway, back to the compare tool. Missing columns or no missing columns. Here's an extra column. Extra column is SW configuration column. Missing rows, a little confusing to me when I first looked at this, but missing row is base 2. So in the modified BOM, base 2 is missing. So here item 1 is base 2, but the second one, item 1 is base 7. Extra row is base 7. So the modified has base 7, whereas the original had base 2. Everything else is the same. Failed rows, there's no failed rows. So there's the BOM compare. Again, a little bit underwhelmed on that one, but just wanted to show it to you anyway. Now let's go into the geometry analysis tool. Let's go back up one level, actually just one level. And use my geometry analysis part file. And it's a simple part, but you can see I got a lot of fillets in here and small faces, things of that nature. Now I should mention under the Evaluate tab in our Command Manager, we can get to a lot of these commands. So for example, I can get to it under Tools, Well, I'm not sure where it is here, but anyway, in our Evaluate command tab, here's a geometry analysis tool. And here's what properties. I'm going to reset all these back to the default. So my short edges are 0.1 millimeters, small faces are 0.1, sliver faces are basically have a high aspect ratio of the length to width of a face. Sharp angles, knife edges, just use the default here, and hit my calculate. And you can see where it finds none right now. But I want to recalculate this, and I'm going to set a little bit more parameters, maybe 1.5 millimeters for the short edges. So what it'll do, it will look at all the edges in the model, and if they're less than 1.5 millimeters, it will identify them for me. Same thing for the small faces. If the minimum dimension on a face is less than 1.5 millimeters, it will do that. Sliver faces, we'll use 1.5 millimeters for all these. And angles, let's set this to maybe 4 degrees. For the knife edges, knife vertices, set this one also to 4. And now hit my calculate button. And it's finding a bunch of stuff here. So it found 140 short edges. If I expand that out, there's one edge. And you can see with that short edge there, it'd be a pretty difficult time to try to mesh this thing with all these short edges in here. So there's our short edges, or a few of the short edges, small faces. So there's a little small face here. This, again, small faces, not just for FE analysis, but a lot of times you try to fill up something with these small faces you'll have issues with. And actually, just luckily, I picked the same face for the sliver faces. And there's a lot of these sliver faces in here because, again, the sliver face is basically the shortest distance to the longest distance. And I could save this as a report also. There's no knife edges, no knife vertices, no discontinuous faces or edges. So there's the geometry analysis tool for you. Again, a pretty nice tool. Now I'm going to get into the find, modify, suppress, and simplify tool that's in here. And I'll just open up my find part. So here's the find part. We've got a whole bunch of fillets in here. Maybe I want to create a configuration or suppress all these small fillets so that I can put it into my upper level assembly, and then the upper level assembly is not going to have too many faces, so it's going to behave properly. So I'm going to use my tools, find modify, and I want to find modify features. So basically I want to find features, what type of features I want to modify or find under my category. Select features, and then what type of features. We'll do simple fillets. And now we can hit my edit button, and this will bring up a dialog box to allow me to, in effect, create the rules for this find. So here I'll just use the default here for the constant radius fillet. So I'm looking for fillets. that have a constant radius that are greater than 0. Of course, you can imagine what this is going to do when I hit my Find Now button. It will find every fillet or constant radius fillet in the model, as you would expect, because we had everything greater than 0. But I'm going to narrow this down. I want it to find all the constant radius fillets that are less than 6 millimeters, maybe. And now if I hit my Find Now, it did not pick the big fillets here. It only found the smaller ones. And now I can just, in this command, I can use my Shift select all these fillets. I can go to my parameters, and I can set my fillet radius to, set the radius to 3. And now I can modify selected. And the modify selected, what this is going to do, it's going to modify all those fillets, regardless of what size they were, that I had selected, to a 3 millimeter fillet now. Pretty nice tool there. So that's the Find Modify feature tool that's part of Utilities, that's part of SolidWorks Professional. I use the same model, but I'll use one of the other tools. I'll do a Find, Modify, Simplify. Now, Simplify allows us to pick geometry, but a little bit different method of picking geometry. We can pick it within use a ratio, I guess you could say, a simplification factor. I want to set the simplification factor to 0.1. As far as feature parameters, hit my Find Now button, and it found all the small features. And again, pretty much the same fillets, the ones that are 3 millimeters now. And so what I want to do with all of these, so I can use my All button or checkbox, so it'll in effect use all these features that it found, or the fillet that it found, and I want to suppress them, but I want it to create a derived configuration called Simplify 1. So now if I hit my Suppress button, it has created a configuration and suppressed all of those fillets that it found. Go ahead and close this out, but now you can see that I've got a simplified configuration and a default configuration. So my default configuration has all the fillets, and the simplified does not. So I'm going to go back to the default configuration, and I'm going to use this same model to do the Power Select tool. So Power Select allows us to define criteria for selecting geometry in your model. Different ways of getting to it. Go to Tools, Power Select, or or I can go to the Select button and Power Select. Brings up the task pane. In the task pane, I can now select what edges, or what I want to select: edges, loops, features, or faces. So here I want to select features, and what filters, in effect what parameters. And I can use a combination of different ones here. Here I'm going to use feature type and fillets and rounds. And now you can see that it selected them. When I hit the new select, it selected all the fillets for us. So now what I can do, I've got them all selected. I can close this power select, and here I'm just going to change colors, but I could right click and save selection to actually save it to a selection list. But here I'm going to change the appearance of it, of all the films that are selected, and I'll just change them to red or orange. Change them to red. So you can see how quickly we can select stuff and do something with that stuff. And now move on to the thickness analysis tool. So I'll open up my thickness check part. And I'll just use my evaluate tab and thickness analysis. What my target thickness? I'll just set it to 1 millimeter. Hit my calculate button. And what it's doing is color coding the thickness. So anything in blue is equal to or above 1 millimeter. And the red stuff is 0.2 something millimeters. So if this were a plastic injection molded part, we'd probably need a more uniform thickness. So I'm going to go ahead and look at it in a section view. And now you can see where I've got some real thin geometry there. Let's fillet here. I'm going to edit that fillet. And let's change that radius to maybe 15. And now you can see I got quite a bit more thickness in here. So let's go ahead and run that thickness analysis again. And there it is. So now I've got plenty of thickness there. And actually the thinnest area is up here in this area here. So there's the thickness analysis tool, again, mainly for people who make plastic parts. Also, I guess you could use it for steel castings and stuff. And next tool I want to show you is the Symmetry Check. So here's a part. Now notice I do have a couple of configurations in here. Right now they're the same, but just looking at it you think I've got symmetry across both of these planes here. But let's verify that. So I can use my Symmetry Check, tell it what plane to check about. If I do my route plane and check it, it says it's good, it's symmetric about that right plane. But let's recheck it, this time using the front plane. And you can see that it's not symmetric about the front plane. unique faces. If I select unique faces and rotate it around, I can see that, okay, well, this one is rounded off, but that one there is not. So I would imagine this one is probably a circular pattern. So let's go into the circular pattern. And edit the definition of it. And you can see where the user forgot to select that fillet feature there. So let's run that symmetry check one more time. Except this time I can have it to where it will automatically split it. And depending on where I select, so if I select that body, it would split it in half. It would split, if I select one of these bodies, it would split it into eighths. If I select this body right here, it would split it into a fourth. So I'll select that and split the part. So now I got a quick symmetric configuration for me for doing FEA analysis. So there's my FEA configuration. It's got the quarter model. My default configuration has the entire model. And basically the default configuration just suppress the two planes in the split face, or the split feature. And the FEA configuration has them active. So there's Symmetry Check, again mainly used for people who do FEA analysis, but it's a quick way of creating a symmetric model for FEA analysis, or symmetric configuration for FEA analysis. Next one I want to show you is the replace annotation. Replace annotation is going to be for drawings. So I'll open up my replace annotation drawing. So to get to my replace annotation, so that'll be under tools, find, modify, find and replace annotation. What do I want to find? I want to find hex. I'll use lowercase, it really doesn't matter. I can say upper lowercase. Hex head bolts. And what do I want to replace it with? Pan, head, machine, screw. And there's some options here about it, whether it's case sensitive or not, what annotations I want to look at to replace it in. Just use the default here. I want to place it in everything. And if I hit my find next button, so it found the text there. And if I hit my replace button, then it's going to replace it with the pan head, machine, screw. Can do a find next, find the next one, replaces that. If I do a find next, couldn't find any more. So that's the replace annotation tool. The final one I want to show you is the feature paint. Feature paint basically allows us to find features and then paste it to either appearances or the feature itself, replace a feature with another feature. So let me do the feature paint part. And right now you can see that I've got a countersink for a 3mm flathead. I've got a counter bore. I've also got a countersink for a #1 oval head. Say I want all of them to be this countersink type. To get to the tool, go to Tools, Feature Paint. Now Feature Paint may not be in your default tools drop down list, but you can customize that to check it, to make it there. So do a Feature Paint, copy properties from. I want to copy the properties from this countersink 3. This is my master. Paste properties 2. I want to paste it to this counterbore and to this countersink. Now I do not want to paste the appearance. I want to paste the actual feature. So now if I hit my apply button, now all 3 of those are countersink hole for #3 flathead machine screw. Now we can also use the copy and paste appearances to other part files. So I'm going to open up I need to close out of the command, and now I can open up a file. And we'll open up the source part file. So we'll bring up our tool again, Tools, Feature Paint, and let's just tile these to where I can see both of them. Copy properties from. I'll use that, not that one. Okay, yeah, we'll copy that one and paste it onto the circular pattern on this other part. But this time I'm not going to copy the feature itself. I want to copy the appearance of the feature. And you can see where it's going to change the color. So now I've hit my apply button and close this. You can see where it, for those pattern instances, it changed the appearance or changed the color of them. So that is all the tools that are part of SolidWorks Utilities, again, which is part of SolidWorks Professional and SolidWorks Premium. Now I want to do a little plug here. Of course, I'm not going to get anything out of the plug, but anyway, all these files actually came out of Chapter 6 of this SolidWorks Productivity Tools Step-by-Step Guide. You can go to the SolidWorks website, https://store.solidworks.com. There's a direct link to that particular book that you can order yourself. And again, what I showed you today was only Chapter 6 of this book. So it's a nice book to have as a reference book. Okay, let's go to questions. Anybody have any questions? If you have questions, you can just put them in the question in your control panel, and I'll be glad to answer them here. I'll give you a couple of minutes. Yeah, look like there are no questions, so we'll continue. And if you do have any questions, you're shy, you don't want to ask questions here, you can always email me at wayne@progressiontech.com or reach me on my telephone, 877-967-5780, extension 295. If you want to see a demo, you can go to the web page, progressiontech.com, and select get a demo on the home page, or you can call same 800 number, extension 1. Next webinar in our series is going to be about integrated process flow, P&ID, piping, isometrics, and SolidWorks, with SolidWorks and SMAP 3D. SMAP 3D is actually not a new product, but we've just been signed on as a reseller of this product. So if you do a lot of big plant design type work, this is a great tool for that. And that'll be Friday, May 15th, same time. And then the following Friday, SolidWorks tips and tricks. So basically just nice little features that you may not be aware of that somebody's going to show you. I do thank you for attending, and have a great week.